All right, let's dive right into this explainer on the Bombardier Q400's Automatic Flight Control System, or the AFCS. If you've ever wondered exactly how pilots command this turboprop through complex skies with such pinpoint precision, well, you're in the exact right place. We're going to decode the logic, the hard limits, and the exact procedures that make this aircraft tick. Here's our pre-flight checklist for today. We'll kick things off with an intro to the Q400 Autoflight, move into flight director lateral modes, then vertical modes, executing ILS and approaches, the autopilot and yaw damper, and finally, system failure enunciations. Let's get to it.
So, Section 1, Intro to the Q400 Autoflight.
Think of the AFCS as the fail-safe brain of the Q400. The really crucial point here is that it's not just one single component, right? It's actually a whole collection of critical, interconnected functions that command everything from your lateral guidance down to automatic pitch trim. It uses dual flight directors for that all-important redundancy, linking your intentions directly to a single autopilot and a single yaw damper to actually move the flight controls.
Moving right along to Section 2, Flight Director Lateral Modes.
Now, let's zoom in on lateral navigation, specifically the VOR mode. When you're navigating point-to-point, this mode is absolutely essential. It automatically transitions through submodes, it arms, it captures the radial, and then it tracks it. But honestly, the truly brilliant part about this system logic is the overstation submode. See, when you fly directly over the VOR station into that notorious zone of confusion, the system actually masks those noisy signals. It just commands a steady heading until the signal cleans up on the other side. It's super smart.
So how do we actually execute this? It requires strict adherence to a 5-step sequence on the flight deck. First, select a VOR or LOC receiver as your navigation source. Remember S for source, always secure your signal first. Second, tune a VOR frequency. T for tune, lock it in. Third, select a course on the Flight Guidance Control Panel or FGCP corresponding to your radial. C for course. Fourth, select your intercept heading target. H for heading. Point the aircraft toward the intercept. And finally, press the nav push button to arm the mode. A for arm. If you follow this strict STCHA sequence, you'll get a flawless execution every single time.
All right, Section 3, Flight Director Vertical Modes. So we've covered moving left and right. Now let's talk up and down. To climb or descend to an exact flight level, you're going to rely on the Altitude Select mode to seamlessly level the aircraft out for you, and it intelligently steps through 3 phases. First, it waits an arm, then it transitions to capture as you approach your target to smoothly round out the flight path, and ultimately it locks into altitude hold. Let's look at the execution phase. This builds into a really simple 3-step flow. First, pre-select your altitude target using the FGCP ALT knob. P for pre-select, pick your target first. Next, press the ALT cell push button right there on the panel to arm the mode. P for press. Finally, maneuver the aircraft towards that pre-selected altitude target. M for maneuver. Just remember P, P, M, and the system handles the rest for a perfectly smooth level off. Now here's a detail you'll want to remember, the 1,000-foot threshold. The system gives you both a visual and an oral alert when the aircraft closes to within plus or minus 1,000 feet of that selected target. It's pretty cool. Your altitude bug on the display actually changes color, and a quick 1-second oral tone sounds off. It gives you unmistakable feedback that your level off is imminent.
Moving into Section 4, Executing ILS and Approaches.
We've mastered lateral and vertical individually, right? So let's combine them for the most critical phase of flight. The ILS approach mode is basically the ultimate multitasker. When the weather drops to minimums, this mode links both axes together to guide you safely down to the runway threshold. It captures the localizer for your lateral alignment and simultaneously tracks the glide slope for your vertical descent, all in one smooth, automated sequence. Pay close attention here, because executing the ILS approach mirrors the VOR sequence we talked about earlier almost perfectly. First, S for source, select your VOR/lock receiver. Next, T for tune. You tune the localizer frequency. But notice this, the system automatically pulls the corresponding glide slope frequency for you. Basically, tune the localizer, get the glide slope for free. Then, C for course, dial in the runway course. H for heading, select your intercept heading. And finally, A for arm, but this time you're pressing the APPR push button on the FGCP to arm the entire precision approach. STCHA.
And for those of you shooting hardcore Category 2 precision landings, keep this number in mind.
1,200 feet. Dual flight director mode activation actually requires a radio altitude to be valid and below exactly 1,200 feet. It's a crucial logic gate. It ensures the aircraft is close enough to the ground to safely utilize radar altimetry for those incredibly sensitive automatic commands.
Okay, Section 5, Autopilot and Yaw Damper.
So, you've got the modes programmed, but who's actually flying the plane? Let's talk servos. This is critical system logic you've got to understand. The autopilot has very strict engagement limits. It's inhibited if your pitch exceeds plus or minus 20 degrees, or if your roll exceeds plus or minus 45 degrees. If you're outside that envelope, no autopilot for you. Also, engaging the autopilot automatically forces the yaw damper on. The yaw damper, on the other hand, it's perfectly happy to operate independently without the autopilot as long as you keep the roll under that 45-degree limit.
And speaking of the yaw damper, check out this physical constraint, plus or minus 4.5 degrees. The yaw damper is mechanically limited to a maximum of 4.5 degrees of rudder travel. That is exactly enough authority to dampen Dutch roll and keep your turns coordinated, but not enough to let the system fight the pilot or accidentally overstress the airframe. It's a really smart safety bound.
Now, what about when things go wrong, or when you need to take over? Here are the autopilot automatic disengagement triggers. The autopilot is incredibly smart, sure, but it will instantly hand the controls back to you if it detects critical sensor failures or manual overrides. For instance, if your AHRS or air data computers fail, or even if they just disagree with each other, boom, it drops offline. Same thing if you manually operate the pitch trim, hit the go-around switch, or if the stall warning discrete is set. The system safely disconnects, hands you the yoke, and sounds a continuous warning tone to let you know you're flying the plane.
And finally, Section 6, System Failure Annunciations. How does the Q400 actually communicate all this to you on the glass? Your primary flight display uses a very strict color coding logic. White text, that means a mode is armed and waiting, like your VOR or glide slope. Green means the mode is actively engaged and flying the plane. But yellow means you have a failure, a status alert, like a mistrim, or an autopilot disconnect that requires your immediate attention. It's designed so you never, ever have to guess what state a mode is in. As we wrap up this explainer, I want to leave you with a real scenario directly from the manual, one that every single Q400 pilot absolutely must be prepared for. Imagine you're flying along and you suddenly see a yellow mistrim message on your display, followed immediately by that automatic autopilot disconnect tone. Are you prepared to manually handle the immediate control wheel transient? Because that wheel is going to abruptly snap the second those servos release. You see, understanding the AFCS isn't just about knowing what buttons to push to engage it. It's about predicting exactly what the aircraft is going to do the moment it hands control back to you. So think about that. Thanks for joining me on this explainer today. Keep learning and stay sharp out there.